The 100-meter sprint is an anaerobic race which mainly uses the ATP system to provide energy and only uses minimal mitochondrial respiration contribution due to the lack of oxygen. The analysis of sprint technique during acceleration, constant velocity, and deceleration of the velocity curve is important. The production of power is generated by high velocity and force, which is used primarily during the start and acceleration phase of the race. This could be highly influential in an athlete's sprint performance. Sprint performance relies on the fast acceleration phase and the following phase of maintaining maximum velocity.
Sprint runners need high rate of phosphate breakdown to aid in the acceleration phase of a sprint and a high power output to maintain high velocity. This normally occurs in the first 4 to 5 seconds of a race. Maximal speed is increased by the lowering interior in the legs. The powerful extension of the leg joints and the muscle mass is crucial in a faster acceleration phase.
Sprint training helps to enhance the ATP system. Kamaji et al. 2000 conducted a study on comparing 100-meter sprinters' performance and pronation angle and found that faster sprinters had a lower pronation angle at various muscles, for example, vastus lateralis and medial and lateral parts of the gastrocnemius.
Speed endurance training tends to fall into 3 categories. The first category is the low anaerobic stress workout, the second category is the medium to high anaerobic stress workout, and the last category is the high anaerobic stress workout. Low anaerobic stress workout is characterized by low to medium intensity trainings with short to medium durations. This will mean that the athlete will fatigue slowly. Medium anaerobic stress workout is characterized by medium to high intensity trainings with short to long durations. This leads to a medium to high stress or higher chance of fatigue compared to the low anaerobic workout. And finally, the high anaerobic workout is characterized by high intensity training. This consists of the duration of medium to high duration and a high to very high stress and fatigue to the athlete. This workout also leads to exhaustive workouts.
Plyometric training is largely used to improve the muscle's ability to generate explosive power. The exercise is made to produce fast, powerful movements and also improves the function of the nervous system. The best pacing strategy for a 100-meter sprint is an all-out effort as it only lasts between 10 to 15 seconds and it uses the anaerobic system. Training which targets muscle and movements used in sprinting action improves speed. Traditional heavy resistance training for strength uses a high force and low velocity format which cannot be used by sprinters as a 100-meter sprint does not use the aerobic system. Furthermore, resistance training must be conducted at high speed to increase power and sprint performance.
Muscle stiffness affects the optimal sprint time of a sprinter. Muscle stiffness is a resistance to change in length. This, in theory, would influence the rate of force development, elastic energy storage, stride length and frequency. Brighelli and Cronin, 2008. Plyometric training PT has been shown to increase sprint performance. The process involves a muscle being loaded and then contracted in rapid sequences. It uses the strength, elasticity, and innervations of muscle to run faster. Hagigi et al. 2012 found significant improvements in sprint times in both PT training and resistance training groups. PT drills included the depth jump, the split squat jump, the rim jump, and the box-to-box depth jump. The RT drills comprised of 2 to 4 sets and 6 to 12 reps of each of the following exercises: leg extensions, leg curls, leg press, and seated calf raise at an intensity of 60 to 90% of 1 RM. Consistent with this study, Brimmer and Slivert 2000 examined the effects of PT on sprint performance and found significant improvements in sprint times as a result of PT. This may be by shortening ground contact time. They did not find significant improvements from sprint training, although the differences between the two training types was not much different. In contrast to these two studies, Fry et al. 1991 and Wilson et al. 1993 reported no significant increase in sprint acceleration or velocity after PT and RT in trained subjects. This may be due to the lack of specific sprint training during the intervention period. Conclusionally, sprint-specific PT plyometric training is the most effective for 100-meter sprinters because it is specific to competition movement and thus having a greater transferability to sprint performance. It is likely that the rates at which forces are produced in the concentric and eccentric actions by the muscles in the plyometric exercises will approximate those in the sprint when the contact times are similar, which is in the acceleration phase.
Oh my god. Why is Rain running third? What? Why is Rain That's school. That's just right. Rain ran second. Here we go.